All right, you got this. Let's learn some math. Welcome to Lesson 1.2.1's Review and Preview. This particular review and preview has a ton of problems, and so rather than walking through each one of those as I do them like I've done on other videos, I'm going to go through each problem and show you the solutions and talk about how I got to them. That way we are not here for 2 hours as we do this. So let's just jump right in. All right, we are on 1-59 and it asks us to use this function that's listed below here to make a table and a graph for the function below. Find the domain, range, and intercepts. Let's start with the table and the graph at the same time. Sounds like a good plan. Now, these are just 5 of the values, and if I could have put 3 in there, but then 3 cubed minus 4 would be 23. Wait, 27 minus 4? 23. That would have been off the graph that we have here. But you can see how I plotted the points. And what this is a cubic function. And the parent function of this would be, so parent function is, we'd say f of x equals x cubed. Okay? And this is just a translation down then of 4 units. So x cubed minus 4. That's how you get that. Now it wants to know the x and y intercept. So let's do the y intercept first. And so if it's a y-intercept, that means the x value has to be 0. So we're just going to go ahead and plug in 0 into the x value. And so that makes it y equals -4. So our y-intercept is 0, -4. And you can see that right here. That's our y-intercept. The x-intercept is a little different. So we're going to go ahead and set y equal to 0. Let me change colors here. We're going to set y, let me get the intercept written. So x-intercept, we'll set y equal to 0 because y will be 0 on an x-intercept. We're going to add 4 and then we'll take the cube root. And that is the value, this is the x-intercept. So this would be the cube root of 4, 0. So down here we'll write that as well. You could also type that in the calculator, but they're both accurate answers. Now it wants to know what domain and range is and are, and I've talked about that a bit already. And you can see that this graph goes to all values for the x. You just don't see all the x values. It's just heading gradually in that direction. But it also goes to all values on the y. So that means it's all real numbers for both. So we'll go ahead and pop those answers in. This is how CPM denotes all real numbers. If this was in interval notation, which is something I hope you get to learn later, we would say the domain was -infinity to +infinity. So easy to write. And the same with range. -infinity to +infinity. But again, what's in the green is what your teacher is probably going to ask you to write for domain and range for all real numbers. Okay, that ends 159. Okay, so 1-60 I really like because it's just basic trig. I love right triangle trig. I love, as we say, let's see here, SOHCAHTOA. So SOHCAHTOA. And all that means is that's just a word, so to speak, to help you organize your thoughts on what the ratios are for sine, cosine, and tangent. So on the first one, we're just going to, and again, SOHCAHTOA only can work on right triangle trig. There's other things that you can use with law of sines and cosines that help you solve other triangles. But on this one, let's just go ahead and dig in. So right here we have our degree measure, 15 degrees. Opposite is x. Hypotenuse is 20. The hypotenuse, by the way, will never be adjacent. So on this one, we're looking at the sine is opposite over hypotenuse. So the sine of 15 degrees equals x over 20. You're going to multiply by 20. That gives you 20 sine 15, which when rounded to the nearest tenth is 5.2. Part B is tangent because you have your angle here, you have your opposite and your adjacent. So this is going to use tangent. So we're going to say tangent, and that is opposite over adjacent. So we have set up our equation here as tangent 15 degrees equals 5 over x. And when the denominator, when the variable's in the denominator, you'll see this little arrow here, means you can just flip the x to the tan 15, and then you can put the tangent 15 on the bottom, which you see right here. Once you type 5 divided by tangent 15 degrees in the calculator, you will have 18.7 inches. And that is the tangent. And while I'm talking about this, don't forget to make sure that your calculator is in degree mode if you're using a Texas Instrument calculator. This is not radians, this is degrees, so very important. Okay, our last one for this one is also a little different because instead of asking for a side length, it's asking us to solve for the degree measure. So we still have to use right triangle trig, but in this case, we have our cosine because this is our adjacent and our hypotenuse. So we are setting it up as cosine theta equals 10 over 11, which we've done on the others. The only thing that's different here is because we're looking for an angle measure, we need to use the inverse trig functions. So we need to hit second cosine on the calculator if you're using a Texas Instrument, because then that will give you the cosine -1, so this inverse information. Then you just put in 10 over 11 in the parentheses. That gives you the angle measure. Again, it has to be in degree mode, but this is cosine, and so we used cosine is adjacent over hypotenuse. And just one more thing, I use this word, or however you want to call it. I'm at a loss for words on what to actually call that right now. It is kind of a math trick to help you remember things, but I also write it in the ratios, and students tend to like that as well, because it just helps them remember that the first letter of each trig function is followed by the ratio. So sine, cosine, and tangent. And that helps you remember a little bit about the ratios that you're going to use on this type of problem. All right, moving on. This is part D of 1-60, and it's a little different because we really don't need right triangle trig. We have one leg and we have the other, and we can just use Pythagorean theorem. But it also says give your answer in both simplest radical form and decimal form, which I thought was kind of funny on this one because 13 is both simplest radical and decimal form. Except for, I guess you could have written 13.0 if you technically wanted to have a decimal in there. But basically it's just a squared plus b squared equals c squared. You plug those into the equation and you solve down to 169 equals x squared. Then you take the square root of that, which is 13. That's really all there is to 1-60. Moving on. Okay, 1-61. Consider the equations 4x minus 6y equals 12. Predict what the graph of this equation looks like. For me, it's going to be linear. And part of the reason I know that is because 4x minus 6y equals 12 is in standard form. Not slope-intercept form, but standard form. And that is ax plus by equals c. And that is linear. So that's how I'm justifying my answer on that one. The next one, it asks you to solve the equation for y. So you'll see that I did that, and I got it into slope-intercept. Okay, so let's take a look at the graph. This is my slope, this is my y-intercept, and that's my slope. Okay, here we go. You'll see that I have started at -2, because that's the y-intercept, and I'm going up 2 over 3, and that is the slope for this particular problem. Let's move to part C. Okay, part C, you will see that I've solved for the intercepts in an easy way. First, I start by plugging 0 into the x to find the y-intercept. When I do that, I get -2, which actually verifies what we did on the previous page. Then the second one is finding the x-intercept. So I'm plugging the 0 into the y value instead, and I solve for x equals 3, and I get the x-intercept, which is, my graph's off a little bit, but it is supposed to be right, let me get a color you can see, right there. Okay. Which form of the equation is best for finding the x and y intercepts quickly? I truly believe that, especially in the large equations, that this standard form is the easiest, because then all you have to do is graph 2 points and draw your line. Now, that is not always the equation you're given. So a lot of times you're given slope intercept y equals mx plus b. So you can graph from that point, but that's kind of up to you. If I'm given an equation in standard form, I prefer to plug a 0 in so I prefer this method when I am finding the intercepts, because then I just need to plot 2 points and graph my line. And hopefully that's a good answer and you understand what I'm talking about. Here we go. I love this effect. Okay. Now on 1-61, we have, they've given us a new equation here on part E. They want us to figure out the intercept. So I did that. I have plugged a 0 into the x to help find the y-intercept. And then I plugged a 0 into the y to find the x-intercept. And you'll see that my intercepts are at 0, 6, which I have here, and then at -9, 0. And then all I have to do is draw my line right through them. And that is what I have there. Hope that helps, and that ends 1-61. On 1-62, this is the first of 2 different problems in this review and preview that talk about domain and range. So we'll go through this a little quickly. What I do here, first of all, on part A, there's no line segment, it's just plotted points. So all you need to know is that there's 3 points, you need 3 domain values. So I look for the lowest, and the lowest is -1, and then I just write them all into this. This is called roster notation. I just put it inside curly brackets, and that lists out the set for domain and range for this particular problem. Same thing here, I look on the range, I'm looking for the lowest value, which is, it's down here. So that's -2. And then the next one up is 1, and then I've got 2. So that takes care of those. On part B, it's a little different because we have an open circle here and we have a solid circle here. So I'm still looking for my lowest domain value, which is -1, and my highest, which is 1. But what happens is I have to, when it's an open circle, like at the top up here, when it's an open circle, I can't put x is less than or equal to 1. I can only say x is less than 1 because 1 is not part of the set. Everything up to 1 is part of the set, but 1 is not. But on the other side, where it's x is greater than or equal to -1, the circle, the point there is solid. So I would put x is greater than or equal to -1. That also affects the range. So the range, the lowest range value is -1, and it is a closed circle, so it is a possible solution for y. So I would say y is greater than or equal to -1, like I've done here. But the 2, again, is open, so there's not going to be, y is going to be just less than 2. And that can be tricky, but you have to remember, open circle means that particular number is just the boundary, the border of that particular set. It doesn't mean it's part of the set. Okay, part C, we are looking at a ray, and that means that the lowest value, again, is -1 for both domain and range, but it goes on into infinity for both. So x is greater than or equal to -1 is the domain, and y is greater than or equal to -1 is the range. On D, we have a parabola. And on a parabola, the domain is always all real numbers, which you see right here written in the form CPM approves, or prefers, I shouldn't say approves, prefers. This is the same thing in interval notation, which I've talked about. Okay, then you have the range. Well, the range, the minimum, because this particular parabola opens upward, it's going to have a minimum. And that minimum is at -2. So we would say that the range will be y is greater than or equal to -2. And that takes care of 1-62. Okay, 1-63, I'm not going to spend a whole lot of time going through this solution because you can look at that when we're done. I'll talk a little bit about it when I'm done. But the problem we have here is, and you can see what I've written in here in green, what you do to one side, you do to the other. And all they've done on this particular problem is multiply the left by x, when they should have multiplied both sides by x. So that is the mistake that they made on this particular problem. When you do that, if you come over here to this side, you have a quadratic. And then you have, and I've talked about the diamond method, we've got a times c because our a is 1, our c is -5. So -5, we have two numbers that multiply to -5, add up to b, which is -4. That is -5 and 1, and that's why this equation is written here. Then it's whatever makes those particular sets of parentheses equal 0. That's why this is x equals 5 and this is x equals -1. That's 1-63. Okay, I'm using in 1-64 just basic algebra again. It wants us to solve for the x value. And as I multiply by x here and here, it turns it into a quadratic. I need to set a quadratic equal to 0, so I move the 6 over. And then I'm doing my factoring again. What two numbers multiply to a -6 but add up to a -1? That's -3 and 2, and that's why you have the equation here. It also asks us to check our answers. So I've checked, and both my 3 and my -2 work. I know I'm going through this quickly, but you can always pause the video in the middle of it and take your time to look at it. But these are both quadratics when you're done solving. Okay. Same thing on B, only B is a little simpler. I don't even need the diamond method on this because I multiply by x on both sides. I get x squared equals 9. Well, if you take the square root of x squared, that's x, and the square root of 9 is plus or minus 3. So down here I have checked both solutions and they work, and that is all you need for 1-64. (1-65) is just asking you to enter different values into this function that we have at the top, okay? And that's all you're doing. And if you look at what I've done here, I've plugged 2.5 into that equation. So 1 over 2.5 minus 2 equals 1 over 1/2 because you have a 0.5. Well, that's easier when you see the fraction. So 1 divided by any fraction just means you're flipping that fraction, and that is 2. And the same thing on 1.75, you end up plugging it in and getting a -0.25 on the bottom. Well, that's 1/4. So -1/4, 1 over -1/4 flips and becomes -4. The last one here on C is a little different because when you plug it in, you do get a 0 in the denominator, and that is undefined. And when it says down below, justify your answer for part C, a denominator cannot be 0. Dividing by 0 is considered undefined. So it is not a real solution. It's not a solution at all. You can't solve it. And that is 1-65. Okay, 1-66 asks you to graph both of these functions, both the y equals 2x plus 3 and f of x equals 2x plus 3. They are essentially the same. In fact, there's a lot of times in math you will take out the function notation and put in a y for simplicity, like when you're finding inverses or intercepts. It just makes life a little easier. But you'll see that both of these tables, even though the writing is, or the typing is kind of small, both of these tables are identical. And I probably should get a color you can see. Both are identical, okay? And the lines are the same. You have the same y-intercept, and you have the same slope. So those are simple. Now, when you go to C, it says, how are the functions in A and B the same? How are they different? Well, they graph the same line, for sure. They both have the same y-intercept and the same slope. The difference comes in the notation. So the notation for part B is function notation. And you can read right here. Both equations graph the same line. The f of x equation is in function notation, which becomes helpful later when merging multiple functions. It is also helpful when dealing with composite functions. And also, like if you're using Desmos and you want to put in like 3 different lines, putting y equals can be confusing because, and even though it'll have different colors, they're all not going to equal y. They're 3 different equations. So just using function notation is a good habit to get into, especially in Algebra 2. All right, moving on to 1-67. 1-67 is basic right triangle trig, which I really, really like, I told you. But you'll see here that I have pointed out that these 2 angles here form a linear pair. They equal 180 degrees. So this 155 tells me that this equals 25 degrees. Then I'm just using my good old SOHCAHTOA again. To help figure out the solutions here. So my 25 is opposite the y, so it's sine of 25 equals y over 3. And then I just go ahead and multiply by 3, and that's what I've done here. And I get it down to 1.2679. If you're rounding to the nearest tenth, it's 1.3. If you were rounding to the nearest hundredth, it'd be 1.27. And that is the first value, that's y. Then also on the x, but this time we're using cosine, because it is adjacent over hypotenuse. We have our x value that we want to find. So it's going to be cosine 25 equals x over 3. Again, you're multiplying by 3. You get to 2.7189. And when you round that to the nearest tenth, it's 2.7. If we rounded to the nearest hundredth, it would be 2.72. And that is all there is to 1-67. Okay. For this one, it's very similar to the last set we did, so I'm not going to spend a ton of time on it. But again, on the domain, I'm looking for specific points. These are all plotted points. My domain, the lowest is my -2, and the highest is 2, and then there's a point in between. The range is -1, 0, and 1. Again, it's based on those 3 points. So you're looking for x values and y values. Part B is another one of those tricky ones where you have the open circle and you have the closed circle. So because of the open circle, my domain, -1 is less than x, not less than or equal to x, because that's an open circle at -1. And then since it's a solid circle at x is 1, it's going to be x is less than or equal to 1, because that means 1 can be part of the set. If I'm looking at range, it's the same thing. -1 is less than or equal to y because it's starting at a solid circle. But again, because of the open circle at the top, it is only less than 2, not less than or equal to 2. So that takes care of B. C, again, it's just array, and for some reason it's kind of funny, but it's very similar, just different looking graph, but it is still x is greater than or equal to -1 because we've got a solid circle there, and range is y is greater than or equal to -1 because they're both heading off into positive infinity. D is a linear equation. And so, or linear function equation, and it's all real numbers. So you see that this is the way again that CPM denotes all real numbers. This is an interval notation in case you're interested. So that is 1-68, very similar to the last one we did just like it. Okay, so this is just a basic algebra problem, 1-69. Write 1 or 2 equations to help you solve the following problem. It's actually easy just to write 1. It is telling us that the rectangle's length is 4 times the width. So our width, we're just going to set at W, which you'll see I did in white over here, but I just want to use the other sides to give you where I came up with it. But the length is 4 times my width, so I'm going to say 4W. And that's basically all I'm doing is adding those two together. So here's my equation. 4W plus W equals 22. I combine like terms, I divide by 5. And I get 22 over 5, which is also 4.4, which you see here. Then I plug that 22 over 5, or 4.4, back into the length, which is 4W, and I get 88 over 5, or 17.6. And so I'm just checking it to make sure. So what I've done here is I have added 17.6 plus 4.4. That gives me the 22 that we started with. So I'm sure that I have got the correct answers for 4.4 centimeters and 17.6 centimeters. and that is 1-69. 1-70 is more algebra, which, I mean, that's pretty good. I like algebra. Okay, part A is asking us to solve for x. They all are asking us to solve for x, but they're all going to look a little different. So originally, I'm going to, you see what I did here? I multiplied both sides by x. Then I get 3 equals negative 51x. You type, or not type, I'm sorry. You divide by negative 51, and then you get x equals a negative 3 over 51. Now, if you type negative 3 over 51 in the calculator, then you hit the math button, and then you hit the fraction, and enter. It will simplify the fraction for you. So try that. If you don't understand what I'm talking about, put a note in the comments and I'll get back to you with a little video. But it's actually really easy. So you type negative 3 over 51. You hit the math button on your Texas Instrument calculator. Then when the math button comes up with a menu, you hit the fraction and then you hit enter and it will reduce it to negative 1 over 17. Okay? All right. B, you see I did cross multiplication here. So I multiplied 8 times x minus 2 and 5 times 10 minus x. You can see all the solving that I did down to x equals 66 over 13. Well, when I do the calculator thing on this answer, 66 over 13 is the final answer. I prefer to leave my answers in fraction form because there are skills that are going to be really important down the road where you understand how to work with fractions, and the more you're exposed to them, the less intimidating they get when you have higher concepts. So I leave them in fraction form. I'm sure you'll have a teacher that might be okay with decimal and they might say nearest tenth, but I just tend to leave things in fractions if I have the chance. Okay, part C is using the zero product property. Okay, and it's also a quadratic, and you'll see down here that I have given you an image of what this graph would look like, so it proves our answers correctly. I did this in Desmos. I just typed this equation as it's written into Desmos, and it gave me this graph. So my x-intercepts, my solutions are at negative 1 and 3. And that is all you need to do on part C. That's 1-70, and we're moving on. Okay, first off, this particular slide is busy, so we're just going to talk about it one at a time. It says use any method. On part A here, it says use any method to find the points of intersections of f of x and g of x. If you look over here, I have graphed both equations. In the green, you have the parabola, and the orange is your linear equation. And then that way it gives me the points of intersection, which I have written here in purple. But I want to solve those and show them to you algebraically. So what I did over here is I changed the function notation to y. I set both of those equal to each other and treated it like a system of equations. Once I got down here and solved for x equals 5 and x equals negative 1, I just picked an equation to plug them back in. So I plugged 5 in to y equals 2x plus 11, and I got 5 and 21. That's my intersection point, which you see in the graph above. I did the same thing, used the same equation, and I plugged in negative 1, and I got negative 1,9, which you can also see in the graph above. Both of those values will also give you the same value if you plug them into the quadratic up here, but that would take more time. So you guys can do that on your own if you like, but it will give you the same intersection points. I just picked the easier equation to plug them in. Part B, it's asking you to add the two functions. And so all you're doing is combining like terms, so you end up with x squared plus 17. That is this particular drawing right here, okay? Part C is kind of interesting once we get done. Subtracting them, don't forget, you've got to distribute that negative to both values inside the parentheses. So it ends up being x squared minus 4x minus 5, which should look very familiar to you based on this up here. This particular equation and this equation are similar. And it's kind of interesting because then you come over here and you look at what their zeros are. Well, those are the zeros that we came up with when we solved originally, right here. Oops, did not mean to do that. Let's see here. Let me erase that if it'll let me erase that without, good, okay. So that kind of helps you with that. So all of the graphs are on this particular, oops, get back to the pen. All of the graphs are here, all of the equations. And that should help you with 1-71. Again, it's a really busy slide, but if you look closely at it, everything is there that you need to understand what we did. Moving on. 1-72 is just like if we were to solve and say, hey, rewrite this equation so it's in slope-intercept form where you're solving for y. You're just doing the reverse here. You're solving for x. So you'll see here what I did is I multiplied, and I'll use a pen instead. I multiplied both sides by the reciprocal, 5/3, because that turns this into 1 right here. And then all I did was multiply. Essentially, I just went across here and put a little line there. So that's the final answer there. You could distribute that 5 if you want, but that's all they wanted you to do was to isolate the x value. On B, it's like our standard form of equation. So this is a linear equation, linear function. But instead of solving for y, for slope-intercept, they want us to solve for x. So you're subtracting 2y and dividing by 3, and that's how you get that answer. Part C is pretty simple. You're just taking the square root of x squared, but you got to remember to put that plus or minus there. I don't like doing white with white in case you get confused, but remember to put the plus or minus there. Okay. Part D is the same. You're adding 100 to each side and then taking the square root, but don't forget, you need that plus or minus there. And that pretty much ends 1-72. Okay, 1-73. You start out with your area equals pi r squared because that is the formula for the area of a circle. But they want to know which is the independent variable and which is the dependent variable. And this is like your x, okay? That's your independent variable, okay? Because the radius determines the area, and that's your dependent, okay? You'll see I did a table in terms of pi. That means pi is still part of the answer instead of multiplied out. This could be 3.14, but no, I'm not going to do that. I'm just going to leave it in terms of pi. You could do the decimal if you wanted, but the reason I did that is when you're on Desmos and you leave it in terms of pi, it gives you these nice little points all the way up. Now, you will see that I've made it so that the radius can't be greater than or equal to 0 because radius cannot be negative. So you can't put a negative radius into an equation. That's why on this particular equation has both sides of the parabola, but that's because we have not limited its domain value. And the only one that makes sense is half the graph. So everything in red is what makes sense on this particular graph. And that gives you both the table that they wanted and the graph. And then, of course, we're talking about the equation, which we have right there. And that is, oh, by the way, this right here is a great way to set domain and range restrictions in Desmos. All you need is the curly bracket after the equation, and it will only draw what you want to see. So that helps a little bit. That's what the red is. It's just half of a parabola. Okay, moving on. I don't know about you, but I think that little origami transition there is very fun. I could do that on all of them, but anyway. All right, 1-74 asks you to plot these 2 points, okay? And it gives you a Desmos activity in the online textbook. So I have done that. I have moved the points to where they're actually being graphed, and then I put the third point in to make a right triangle. The third point could also be somewhere up here in this area, but I decided to go with where I've put it here. Okay, then I just count my units. That's all I did and this is 3 and this is 7. And then I did the Pythagorean theorem to find the hypotenuse. And that's the distance they wanted. They wanted to know the distance between the 2 points. There is a distance formula out there too, but CPM focuses a lot on the slope triangles that help you find hypotenuse. So you're just going to use the Pythagorean theorem for that. So 3 squared plus 7 squared, that equals 9 plus 49, which is the square root of 58. And you'll see over here I did both the simplest radical form and the decimal approximation because it rounds to 7.6. Now, when you're looking for the slope, that's just rise over run. Okay, so rise over run. Okay, this is the rise, 3, and 7 is the run. Now, on mine, because of the way I wrote the equation, I have a negative slope, so it's going to be a negative 3 over 7 because it's going down to the right instead of up to the right. So it is a negative 3/7 is the slope. Okay, and that is 1-74. On 1-75, if the number 1 is the output for Carmichael's function machine, which we'll have him make a grand entrance here, how can you find out what number was dropped in? Find the numbers that could have been dropped in. Well, you're just going to set your equation that they've given you in the function machine equal to the value of the output. And that is x squared plus 2x plus 1. But then I want to get it over because I see that I have a quadratic. I see that I have an x squared term, so I know there's potentially 2 solutions. So I'm going to move the 1 over by subtracting, which gives us x squared plus 2x equals 0. Then I factor out an x from both. And when I do that, I have this, the only value this could be is 0 because there's nothing else that would make that 0. Did that make sense? I hope. This set of parentheses has to be x equals -2 because that's the value that makes it equal 0. Now, it also is a good idea to check your solution. You don't always have to do this, but this is for me to help prove to you why I'm saying it is correct. So I'm plugging -2 into the original, and I'm plugging 0 into the original, and both of my answers check down to a 1. So that means that I could put either a -2 or a 0 in, and I will get a 1 out. And that is 1-75. At this point, pause the video and read the pink line. Put a 0 in for every x. All right, find the error in the solution at the right. Well, it's actually below, but describe the error and solve the equation correctly. This is an order of operations error. Okay, what they did is they subtracted the 10 minus 4. And you can't do that because when it's PEMDAS, it is parentheses first, exponents second, multiplication and division left to right, and addition and subtraction left to right. These are common mistakes that people even in the pre-calculus level make. And I notice I have my little cursor in there, so sorry about that. So then when it's done correctly, you'll see, I'll let you go ahead and look through and see what I did. But instead of 6 times x minus 1, you end up with 14 minus 4x. I also did check it. I used that 12 over 7 and plugged it back in just to check and make sure my answers were correct. And they are. I got down to 50 over 7. And I've already spoken earlier about the fact that I like to keep things in fractions. I don't like working with decimals that go on forever, which is also known as an irrational number, because they're not as exact, and I like precision. If I can use precision and find it, I'm going to do it. That's why I left it as 50 over 7. In addition, if you do the little calculator trick I talked about earlier, 50 over 7 will still stay at 50 over 7. And that is an improper fraction, but that's okay. All right. Improper fractions are often easier to work with than a mixed number. Okay, that ends 1-77. Well, that pretty much ends my video for this particular review and preview. Thank you so much for watching. If you like this video, please hit the subscribe button below. I am going to be continually putting out new videos. That way you don't miss any videos that come up that help with homework and help with lessons, things like that. For Algebra 2, I am also going to be starting Geometry in Algebra 1 soon. But thank you again for watching, and subscribe, and give me a thumbs up too. That wouldn't be too bad either. Have a good one, and see you on the next video.